All right, y'all, here for one of my favorite lessons of the year. Today we're going to learn how to derive basic functions without using limits. So all last week we were deriving functions, but we were using that tedious difference quotient formula, that limit as x approaches a, or the limit as h approaches 0, and we had to cancel a whole bunch of stuff to get our derivative. Now we will not be using that anymore. Going forward, we're going to be deriving functions using these basic differentiation rules, and you'll see that it's much quicker and much simpler. This is the trick that I was talking about last week. Some of you got onto and were using, and some of you were just waiting patiently for me to teach it to you. Well, the time has come. Okay, so we're going to be deriving a couple different types of functions today. Okay, so first things first, these first two we're going to do are kind of simple. So first we'll have the derivative of a constant function. It says the derivative of a constant function is 0 for any real number c. Okay, so all of these examples we have here are just numbers. Okay, so if I ever have a function like, for example, part B, s of t equals 45, that's just a number. It's just going to look like a horizontal line. And remember that the derivative is the same thing as slope. So the slope of this line is going to be 0. The derivative of a constant function is going to be 0. Okay, now before I just get too excited and write 0 everywhere, I want to make sure I'm using proper notation. So here on part A, my function was y equals. So that means that the derivative would be y prime equals 0. Okay, on B, I had s of t. So the derivative would be s prime of t is 0. Okay, on C, I had f of x. The derivative would be f prime of x is 0. Okay, now on this last one, part D, k usually represents a constant. And remember that pi is just a number. So everything here is just a constant number. The derivative is 0. Okay, the derivative of a constant function is 0. Okay, so there's the first one. Okay, now we're going to go on to the single variable rule. Okay, so it says think graphically about the line y equals x. So anytime I just have that single variable, that's going to be my linear parent function, y equals x. Okay, and think about the slope. Again, the derivative is the same thing as slope. So the slope of this line is 1. The derivative of a constant, or sorry, the derivative of a single variable is 1. Okay, so on part A, I had f of x equals x. So f prime, I want to use red. F prime of x, the slope is 1. Okay, it doesn't matter what letter I use. I could use x, I could use t, I could use p, I could use v, whatever. Okay, so s prime of t, it's just a single variable, the slope is 1. X prime of t is 1. Okay, just think of it as a line. What is the slope? Okay, so now we're going to get into the more interesting stuff. Okay, the power rule here. Okay, so you're going to be using the power rule anytime you see a variable with an exponent. Now, it won't always look like a variable with an exponent, but maybe sometimes you can write it as a variable with an exponent. Okay, so here it is. Here's the power rule right here. It says when we're taking the derivative of a variable with a power, I guess they said if n is a rational number and we have a function x to the nth power, it'll be differentiable. And what we're going to do is we're going to take that exponent and we're going to bring it out to the front. Okay, and then we're going to reduce the original exponent by 1. Okay, so let's try it here on part A. They gave me the function y, so I'm going to be talking about y prime, the derivative. I'm going to take that exponent of 2 out to the front, copy my variable, and reduce my exponent by 1. So it was 2 minus 1 is just 1, or I have 2x. Okay, part B is a little bit of a better example. They gave me f of x, so the derivative would be f prime of x. Okay, it was x to the 4th power, so I'm going to take that 4 and bring it to the front. Copy my variable, and then 4 minus 1 is 3, 4x cubed. Okay, now sometimes, like I was saying earlier here on part C, I'm not seeing an exponent. This is the power rule. I can only do this when I'm seeing a power, an exponent. So sometimes I'm going to have to rewrite my function so that it has an exponent. Okay, so this is where notation comes in, and it's very important. If the function was y and I'm just rewriting it, I'm not deriving yet, I want to continue to just say y equals. This is still the same original function. This is not the derivative. Okay, I can write the square root of x as x to the 1/2 power. Okay, now I see a variable with an exponent, I can apply the power rule. Okay, so again, notation is important. I'm ready to derive. So now I'm talking about y prime. I'm going to bring that exponent to the front, copy my variable, and reduce the exponent by 1. So 1/2 minus 1, or 1/2 minus 2/2 would be -1/2. Cool. Let's try example D. Okay, again, I'm not seeing an exponent here, so I want to rewrite my function. I'm still talking about plain old g of x, and I can write this as x to the -1st power. Okay, now that I see my exponent, I'm ready to derive. G prime of x equals. I'll take my exponent and move it to the front, -1. Copy my variable, and then -1 minus 1 is -2. Okay, you don't have to write this one in front. Oops. -x to the -2nd power. Okay, on E. Now I'm seeing an exponent there, but I want it to just look like a plain old, simple as possible variable with an exponent. I don't want to see a fraction. Okay, so I'm going to rewrite this function. Plain old f of x. If I have something in the denominator, I can move it to the numerator by making the exponent negative. This is x to the -2nd power. Okay, now no more fraction. I'm ready to apply the power rule. F prime of x. I'm going to move that -2 to the front. Copy my x, and -2 minus 1 is -3. All right, same thing here on part F. I don't like that there's a fraction, so I'm going to rewrite my function y equals, and this will be x to the -2/3. I'm ready to derive. Y prime equals. I'm going to take that -2/3 and bring it to the front. Okay, and then 2/3 minus 1, or sorry, -2/3 minus 1, or -2/3 minus 3/3 would be -5/3. Okay, so this is the power rule. This is how we can find derivatives with some more ease. Okay, let's make it even a little bit more interesting. Okay, all of these functions that we just derived were just my plain old x with an exponent. Okay, general power rule. Okay, so now I might have a coefficient in front of my variable. It's the same rule. Okay, when I end up bringing my exponent to the front, all I'm going to do is I'm going to multiply it by whatever coefficient was already there. Okay, so here on part A, okay, my function was y, so we're now talking about y prime, the derivative. So when I bring my exponent to the front, I'm going to multiply it by that 3 that was already there. And then I'm reducing my exponent by 1. Okay, the derivative here would be 6x. All right. Example B now. We had s of t, so now we're talking about s prime of t. All right, and we're going to multiply. -5 times 3 is -15. And instead of an exponent of 3, I'll have an exponent of 2. Now, here on part C, same thing. I'm not seeing an exponent. I need to rewrite my function so that I can see an exponent. Okay, so I'm not deriving yet. I'm still talking about the original function, y equals. And instead of root x, I'm going to write x to the 1/2 power. Okay, now I'm ready to apply the power rule. Y prime equals. 6 times 1/2 is 3. And 1/2 minus 1 is -1/2. Nice. Okay, now on these bottom 3, again, I have fractions. I don't want to see it as a fraction. I'm going to rewrite it. Okay, so this will be g of x equals 3x to the negative second power. I'm just going to go ahead and rewrite them all and then I'll derive. Okay, on E, f of x equals 4x. I know it's a square root, so 1/2, but it was in the denominator, so negative 1/2. Okay, and then for f, I'm still just talking about regular old y. I've got a -8 on top. All right, x. So it's on the denominator, so I know it's going to be a negative exponent. It has an exponent right attached to the x of 4 and a cube root, so 4/3. Okay, I did not do any calculus here. I just rewrote my function. It's still the exact same function. I did not change it at all. Well, I changed it. I rewrote it in a different way, but they are equivalent functions, I should say. Now I'm going to derive. I'm going to use my power rule. Okay, I'm going to get the slopes or the derivatives. Okay, g prime of x. Your notation here is important. 3 times -2 is -6. And then my new exponent, -2 minus 1 is -3. Done. Okay, on E, now we're talking about f prime of x, the derivative. 4 times -1/2 is -2. And -1/2 minus 1 is -3/2. Whoa. All right, last example here, y prime equals. Okay, now this one kind of trips some people up. I have -8 over 1 if you want, times -4/3 x. Okay, and then my new exponent, -4/3 minus 3/3 would be -7/3. So if I clean this up, -8 times -4 is +32 over 3 x to the -7/3. Okay, you could have skipped this step here if you felt like you could do that in your head. Okay, so this was our power rule, kind of as complicated as that's going to get. Okay, now the next rule here is the sum and difference rule. This works out exactly as you hope it would. Okay, this is just saying if I have a binomial or a trinomial or any sort of polynomial that I'm adding or subtracting these terms that I could apply the power rule to, they're just saying take the derivative of each term. If there's a plus sign, you put a plus sign. If there's a minus sign, you put a minus sign. Okay, so it's not any more complicated than it's already been. Okay, so here on part A, okay, there's nothing for me to rewrite. Everything has an exponent, nothing's a fraction. I'm ready to go straight into deriving. Okay, f prime of x equals. Okay, the derivative of x cubed. I'll bring that 3 to the front and subtract my exponent. Minus the derivative of 5x squared. I'll multiply. 5 times 2 is 10. And my new exponent is just a 1. Plus the derivative of 2x. Okay, think about the line. Y equals 2x. What is the slope? It's 2. Okay, and then the derivative of any constant would be just 0. So the derivative of 7 is 0. Okay, doke. Got that one. Going over to part B. Okay, now I see a fraction, yes, but it's the coefficient. So I'm fine with that. There's no square roots or anything I need to rewrite. So I'm good to go. Let's use the power rule. Y prime equals. Okay, 2/5 times 5 is just 2. And now instead of an exponent of 5, I'll have an exponent of 4. Okay, the derivative of x to the 4th power would be 4x cubed. All right, and then 3x squared, 3 times 2 is 6, x to the 1st power. The derivative of 1 is 0. Nice. Now on part C, I'm going to have to rewrite this equation because I'm seeing some roots. Not every x has an exponent. Okay, so again, I'm not deriving yet. I'm still talking about plain old g of x. Okay, if I have the cube root of x, I can write that as x to the 1/3. And then I have 5 times root x, or x to the 1/2 power. Now that I'm seeing my powers, I'm ready to derive g prime of x. Okay, so for my first term, I'll bring that 1/3 to the front. And then 1/3 minus 1, or 1/3 minus 3/3 would be -2/3. Okay, plus 5 times 1/2. I'm just going to say 5/2. I'm not going to make it any more complicated than it needs to be. 1/2 minus 1 is -1/2. Okie doke. Last one here. Okay, so far my first term looks great. My second term looks great. My third term is a fraction. I'm going to have to rewrite. Okay, so y equals 5 times x to the 3/2 minus 6 times x to the 5/2 plus, and I'm going to say 4x to the -1st power. Okay, again, I did not derive. I just rewrote the function in a different way. But now everything has a power. I'm ready to use the power rule. Y prime equals. Okay, so 5 times 3/2. Well, 5 times 3 is 15, and that would be over 2. 3/2 minus 2/2 is 1/2. Okay, now I have 6 times 5/3. 6 times 5 is 30. Divided by 3 is 10. And 5/3 minus 3/3 is 2/3. Okay, for my last term, 4 times -1 would be -4. And -1 minus 1 is -2. Nice. Okay, just in the interest of time, I'm going to skip example E, but I do want to talk about example F because there's one kind of like it. Well, there's a couple kind of like it on the homework. Okay, so here, yikes, we haven't talked about when it's a fraction like this. I have a whole bunch of terms on top and an x on the denominator. I believe tomorrow we're going to learn something called the quotient rule, where we're going to learn how to derive functions that are being divided, because it's not as simple as the sum and product rule. It's not just the derivative of the top and the derivative of the bottom and call it a day. Okay, but for now we don't know that. So what I'm going to have to do is I'm going to have to rewrite this function. And I want it to look like a basic trinomial. Okay, no fractions or anything like that. So what I'm going to do is I'm going to let this denominator be shared by every term in the numerator. So I have 8x cubed over x plus 4x squared over x minus 3 over x. Okay, so right now I have my 3 different terms. Okay, but I still have these x's on the denominator. I don't like that. I want to clean it up. I want to simplify. Okay, so again, I'm rewriting f of x equals. Okay, if I have 8x cubed over x, I can subtract those exponents. Okay, instead of x cubed over x, this would be 8x squared. Okay, my second term, if I have x squared over x, I have 4x. And then this last term here can be minus 3x to the -1st power. Okay, now I see that I have my 3 terms. They each have an exponent. They each have a power, no fraction. I'm good to go. I can apply the power rule. F prime of x this time, I'm talking about the derivative. 8x squared, the derivative there, 8 times 2 is 16. X to the 1st power now. All right, I have 4x. The slope of that line would just be 4. And then -3 times -1 is +3. And then -1 minus 1 is -2. Okay, so you might have to do something like this where you let that denominator go to every term on the homework. There'll be a couple like that. Okay, so that's everything you need to know about the power rule and deriving polynomial looking type functions. Okay. Oh, something else to mention about the homework. So I told you there'll be some like this where it's it's like a quotient you're dividing, but you need to simplify it to look like a trinomial. You also might see something where we're multiplying on the homework. And when I say might, you clearly will, but you will see something like this on the homework where you're multiplying. Same thing, we're going to be learning this tomorrow. It's called the product rule. It's not just the derivative of the first binomial times the derivative of the second binomial. So what you'll have to do for today is you'll have to expand this, get a trinomial, and then use the power rule for each term. Okie doke. So let's go back here. Okay, so now I just want to tell you guys some other basic derivatives that you'll have to have memorized. Okay, so we're going to talk about sine, cosine, and tangent, and then we'll talk about e to the x and natural log of x. Again, these are derivatives that you need to have memorized. If you are interested in seeing why these derivatives are what they are, I invite you to head to YouTube, say proof of derivative of sine, proof of derivative of cosine, etc., etc., because they do have mathematical reason, but just in the interest of time, I'm just going to tell you guys what the derivatives are. Okay, so the derivative of sine is going to be cosine. The derivative of cosine is going to be negative sine. And the derivative of tangent is going to be secant squared of x. Okay, so a good way to remember the sine and cosine derivatives, I'm going to come out to the side here. Oops. Okay, and really quickly, I'm just going to draw my x and y axis. Okay, and remember that cosine is an x thing, so over here is where positive cosine is. Over here is where negative cosine is. And sine is a y thing, so positive sine up here and negative sine down here. Okay, now to get the derivative, you're going to go in a clockwise rotation. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. And the derivative of negative cosine is positive sine. Okay, so that's an easy way to kind of remember. In the past, I've seen people draw this on their test. Okay, so again, you will need to have these derivatives memorized. Okay. Moving on, they kind of just talk about it on the calculator. Okay, let's talk about e to the x and natural log of x. Again, these are two derivatives that you will need to have memorized. Okay, the derivative of e to the x is easy. If my function is e to the x, the derivative of e to the x is e to the x. Okay, it's the same as the original. The derivative matches. E to the x, the derivative is e to the x. Okay, then we have natural log of x. The derivative of natural log of x is 1 over x. Again, those are two that you're going to need to have memorized. Okay, so let's try it out. It says use laws of logarithms to find the derivative of the following. So here on part A, they're saying, what's the derivative of natural log of x cubed? I don't know. I only know the derivative of natural log of x. So we're going to have to use our logarithmic rules here. I'm going to write some of them down. Okay, so first, if I have natural log of a variable to some power, I can always move that power to the front. Okay, we're also going to need to know if I have the natural log of two things being multiplied, I can put them each in their own natural log and add them. And then finally, if I have the natural log of two things being divided, I can put them each in their own natural log and subtract them. Okay, these are 3 log rules that you should already know, and you're going to need to know to rewrite some of these functions. Okay, so let's jump in. Okay, so here on part A, I have the natural log of x cubed. Again, I want to be able to see natural log of x, just natural log of x. So before I derive, I'm going to rewrite, still talking about regular f of x. I'll take that exponent of 3 and move it to the front. 3 times natural log of x. And now I'm just seeing a plain natural log of x. Okay, so I'm ready to derive f prime of x equals. Okay, this 3 is being multiplied. It needs to stick around. So I'm going to have 3 times, and the derivative of natural log of x is 1 over x. So this would be 3 over x. Okay, be careful here. It's a common mistake to say, oh, well, the derivative of 3 is 0. So it's just natural log of x. If we're multiplying. If it was 3 plus natural log of x, then yeah, it would be 1 over x. But this is 3 times, so that 3 needs to stick around and be multiplied. Okay, over to part B. Okay, so I have 2 things being multiplied inside, so I'm going to rewrite my function g of x, and I'm going to split them each into their own natural log and add. But I'm also seeing some exponents. So I'm going to move those exponents to the front. 2 times natural log of x plus x times natural log of e. Okay, so I'm seeing natural log of x. That's great. Perfect. Natural log of e is just 1. So I'm going to rewrite this one more time. I've got 2 times natural log of x plus x times 1. And I'm ready to derive g prime of x. Okay, so I have 2 times natural log of x. The derivative of that is 1 over x. And the derivative of x is just 1. Nice. Okay, I'm going to skip C in the interest of time. I'm going to go to D. Okay, I see 2 things being divided inside of my natural log. So I'm going to rewrite my function. They're each going to get their own natural log. Oops. E to the x. And I'm going to subtract them. Natural log of 3x. Okay, now again, I'm seeing things being multiplied. I'm going to break them up with a plus sign. I've got natural log of 2 plus natural log of e to the x minus natural log of 3 plus natural log of x. Okay, and then finally I'm seeing an exponent there that's got to move to the front. So I've got natural log of 2 plus x times natural log of e minus natural log of 3 minus natural log of x. Okay, now I'm seeing natural log of e. I know that's 1. So I've got natural log of 2 plus x minus natural log of 3 minus natural log of x. Okie doke. Now, I'm seeing natural log of x. I know how to deal with that. I'm seeing a plain old x. I know how to deal with that. But I'm also seeing natural log of 2 and natural log of 3. Remember, natural log of a number is just a number. I don't know exactly what natural log of 2 is, but it's a number. It's a constant. So the derivative of natural log of 2 is 0. The derivative of x is 1. The derivative of natural log of 3 is 0. And the derivative of natural log of x is 1 over x. I've got 1 minus 1 over x. All right. Okay, so the hardest part about this is just rewriting using your natural log rules, not even the calculus. The calculus is the easy part. Okay, let's try it again with this one. I've got a couple things being multiplied in there, so I'm going to rewrite with a whole bunch of plus signs. I've got natural log of 4 plus natural log of x cubed plus natural log of e to the x. Now I'm seeing exponents. I'm going to move them to the front. Again, this is not part of my deriving, moving the exponent to the front. This is the part of my natural log rules. I'm just rewriting. I'm not doing any calculus. This is an equivalent function. Natural log of 4 plus 3 times natural log of x plus x times natural log of e. And then finally, I know that natural log of e is 1. So I've got natural log of 4 plus 3 times natural log of x plus x. And I'm ready to derive. Natural log of 4 is just a number, that's 0. 3 natural log of x would be 3 over x. And the derivative of x is 1. Nice. Okay. So that's where I'm going to go ahead and stop today's video. You've got a couple problems here for homework. Okay, some of these you're going to have to rewrite. Okay, for example, This one, y, you could rewrite it as 1/6 x squared plus 1/3. Okay, share that denominator. Down here, you're gonna have to factor that sum of cubes, okay, and cancel out the denominator. Multiply your binomial, share your denominators here on 11 and 14. And on 10, same thing. I have 4/3 x squared minus 5/3 x plus 2. Okay, so try it out. Tomorrow in class, I'm going to go over some of these. And let me know if you guys need any help. Of course, I'm always happy to help you out. So hope you have a great rest of your day, and I will see you when I'm looking at you.